All right, this is a Monroe LA 160X. Um, I had shot a clip of this, like kind of like an intro before I started working on it, but the audio was messed up. So I'm gonna like simulate an unboxing here by removing this box. Wow, look at this. I've never seen this before. Anyway, so this I don't research these enough before I talk about them, so I'm not gonna. I don't know when they made this, but it's clearly forever ago. I mean, I would guess 20s and 30s just based off what I'm seeing. Um, let's see. I have removed the whatever case. I removed the little decimal plate here. Put a little bit of oil on it. As you can see, I haven't really done any cleaning because I've got a ton of this really nasty. This is what happens when you do everything the wrong way. Like this thing, I got it for like 30 bucks on eBay, and I was like, yeah, okay, we got a bunch of rust here, and really should have removed all of that before putting any lubricant on any of this, but now I've got a very greasy um, and rusty little thing. But it is working a little better now. Keys are, oh, okay. Yeah, so obviously PSA, you never want to just do this where you just kind of start putting a bunch of grease on things without cleaning it off and disassembling it first because that's just gonna mix with you know it's especially in something that has a like a plain bearing where you have a bunch of crap getting in there that's gonna just mess it up even more. And it's only a temporary fix, which is all I'm going for right now, just to get it kind of functional. Let's see. Haven't really, like I said, I've removed some things, lubricated some things. Haven't made any adjustments yet, any major ones at least. The clearing, oh, okay. So the clearing would work. However, I guess I'm going to have to get into the main issue I'm having right now because it's preventing me from demonstrating it. So I've got the original cord plugged in. Um, you can tell that it's original because, it's just I could very quickly turn this into just a shoestring wrapped thing here if I just played with it a little bit, but it's doing the job for now. Obviously, this is not a long-term solution, but when I turn it on, the motor does run, and it runs, and normally that would be good, but it's not. It won't stop running. Um, you can see some arcing going on in there. I didn't know that was happening. But I think what are we doing? Subtraction. Now we're doing subtraction, so I'm able to shift the operation over, and you can see the little reversing clutch back there. Um, I don't think that's supposed to be stuck like that. Um, Obviously, I'm not. There we go. I'm gonna cut it off real quick because it's gonna start to smoke if I just let it run. Um, okay, so I put some tape on the bell because that was really, it's cool, but it's really, I'm sure you understand. Anyway, when this thing gets locked halfway through an operation, like has been happening with me every single time I try to do anything on it. Let's see. So like right now we're stuck halfway through, so that's why I can't clear anything. I can't. Apparently we're in a place where I can press the operation levers, but there's certain spots on a revolution where that's not going to be possible. Anyway, I'm going to go ahead and just, yep, there we go. Okay, so now it's where I can move the carriage, but just popping this open real quick. Try to get a light in there. The actuators were mostly frozen, I want to say. I mean, like the ones on the left side of the keyboard certainly were. I don't know. My light's falling apart. I bought it on Amazon. Yep, okay. Yep, I think we might. It's going to fall right on my face while I'm trying to film this. Anyway, I don't know. This one seems to be one that a lot of the videos I've seen on this, like everything is super gummed up and things are just really nasty. I think I've gotten pretty lucky with this one so far, despite the appearance. I mean, when I got this on eBay, it was like I said, it was like $30, and no takers. It had been up there for like 6 months, and I was like, yeah, like this is. It was like $10 shipping. I was like, it's either gonna show up, completely just powderized, or it's gonna be somehow perfect. And I think I'm closer to the perfect end of things than I am on the powderized end of things, but I'm probably gonna eat those words because I haven't fixed it yet. I'm just kind of, it's always something that happens halfway through this, so I don't know. I'm gonna have to get more into this than I had originally hoped. Anyway, there's a little intro video on the, what is it? I forgot already. LA 160X, I think. Doesn't have the division switch lever here, so it's just your basic whatever. Doesn't do a whole lot.
Okay, so quick update on trying to get the transmission all cleaned up. There was a little bit of grease that I'm not really able to get to, kind of in between the gears there, so I wasn't sure how much of it I really needed to remove, so I figured I would play it safe. So, my idea was, okay, I'll just calculate the moment of inertia of the ring gear and the sun gear in the middle, and then have to see how much of what the density of the grease is, and then probably just go through a whole thing and try to, I guess, calculate the how much the change in the moment of inertia of the gear is going to affect the system. But then I realized that more grease is going to cause more um, grease to build up over time. So then I have a differential equation to solve, actually a system, and I was just about to do some arithmetic and get started on that when I realized that my calculator is taken apart. It's just this really, kind of funny situation. But then I realized it's okay because I have an old slide rule. So after all that, I think I might be able to get all this grease off after all. So you have to understand, this was a lot funnier in my head.
All right, so I made a mistake trying to clean these keyboard levers, and I'm going to kind of show what I did and why that was so stupid. But to show what these things are, so I've got my little nasty Tupperware full of my mistakes that I've made here. But so these parts are the keyboard levers, is what I'm going to call them, but we're kind of far away. But basically, all these do is there's these little nubs in here. These all sit. Uh, they mate with that nub, and they just kind of rest there. So there's like, I think 16 of these, which this is an uh, eight, 8 rows of keyboards, whatever, eight keys. There's eight numbers up here. You can type in an 8-digit number. But for each one, there's 2 levers, and all those do is one of them is going to push the 5 Leibniz number actuator, and the other one's going to push the 1, 2, 3, 4 actuator to just add whatever the number is. So I removed these because they were, impossible to really get to from in the machine, and they're very nasty. Uh, but when I took these out, like this one here, they're all like this. Um, I don't focusing is difficult for some reason. All right, so these surfaces right here, wow, this is so bad. and they're all like this. It was so much better. But they were like a little bit, maybe, I don't even want to say rusty, but like the surface finish was kind of nasty. And I'm pretty lazy and impulsive, so when I see something like this, I'm like, oh, hey, you know what I'll do? I'll just like quickly put some phosphoric acid on there, and then just kind of eat away at all the nastiness. It'll work. Unfortunately, I should have known this from other machines I worked on. The older, you can tell how porous the metal is. I mean, even before I etched it, like this, using my fingernail, I mean, looking at it, it was like, yeah, this is a very, very porous steel. Um, which, it's from the 30s, and I'm sure this wasn't like the most, I mean, this is stamped. Anyway, put them out on there, and then basically what happened was it leached the carbon out of the steel, and it also got into the pores and didn't come out. So that's one thing that I remember from the last other times that I've really screwed up with acids and porous metal is this stuff, reeks like phosphoric acid. It's not quite like uh, it's not quite like hydrochloric. I mean, it's a specific smell. It's not pleasant. But after I had, cleaned it off and ground it down and like washed it, it still smelled like phosphoric acid, and that's when I was like, oh, that's not good. Now, even now, they still kind of smell like phosphoric acid, even though I've brake cleaner, tried everything I could, brushed them down, coated them in this, which is it's kind of like a WD-40 if it was even more waxy. Um, but this looks terrible, and I'm not going to leave it like this because like I was trying to take the easy way out. this this one's like all black. There's no more carbon in that steel. It's all come out to the outside through the diffusion. It's diffused. Anyway, so what I'm going to do is I'm going to take my little Dremel thing with some of these guys, and I'm just going to try to grind it down until I get them to look better than this. It's really just an aesthetic thing at this point. And then I'm going to give them another coating with the weird waxy WD-40 stuff right here, and hopefully I can get these looking better than that, because like I have no idea how that was. It was like the worst outcome possible with these things, and I've got like 16 of them to polish down. But I'll give an update with how those turn out, and it's another, I guess, quick warning. I'm with these machines, I like to just impulsively do something that I don't research and like don't really think too hard about it, and then I end up with this kind of stuff. So anytime you're doing anything with chemicals, especially acids, it's probably a better idea to like make sure that's not going to be a really stupid thing that'll set you back a good, I don't know how many hours it's going to take for me to undo what I've already messed up here, but word of warning. Okay, so the method I decided to employ to polish up these little steel lever things was one that's typically used when you are preparing a metallurgical sample for optical microscopy or other testing to examine the microstructures. And those are going to look something like this. Um, See, typically you start by mounting these samples very precisely in a thermoplastic rosin like this. In this case, this is a 1018 normalized steel, so it's pretty similar to the types of steel I was working with those little lever things. And this process is it's really involved. It requires laboratory equipment, but it requires just successively finer polishing on a polishing apparatus up to I think like a diamond grit. We're talking like I don't know 4,000, and then finally etching with usually some type of nitric acid, so you can reveal the microstructures and the grain boundaries. So after doing that, let's see, I ended up with I mean, the results, I gotta say, the results are basically consistent with what I remember from materials lab, where you polish it and take it to the lab instructor, and then they feel bad and they give you a different sample that they actually prepared properly so that you can do the lab. Um, and usually, when you're doing this kind of procedure after you've completed the microscopy, you usually would want to move into like a hardness testing, which is like the local plastic deformation of the metal, so you can test it's a material property. It's a bunch of different hardness tests, but all of them require using some kind of an indenter with very calibrated force, and then taking proper readings to see what the actual hardness level was. That I think before I mentioned that, hey, just using random chemicals um, haphazardly and irresponsibly tends to yield bad results. Case in point with the stupid other things, and then with this especially. But I've decided that instead of doing the right thing, which would be whatever the thing is I don't want to do usually, that I'm going to go full throttle and double down. And I am of the belief that there is absolutely no paint known to man that can withstand reagent grade methylene chloride, which this is kind of the point where I might have to like make an actual PSA with this. Like, don't do what I'm about to do. This is there's a reason they banned this stuff. There's a lot of solvents out there that I'm like, I put on PPE because I'm like, okay, I know I should put PPE on, but like if I really need to do something really quick, it's just kind of a whatever. This is one of the only solvents out there, not like acids or whatever, but like just straight solvents. This is one of the only ones that I have like a visceral fear of. Um, I'm really not a fan of this stuff, and so this is going to be one of those times where like, hey, I'm actually going to, although I'm applying this, which is a very over the top and irresponsible thing to do, I am going to be safe with how I deal with that, because this stuff is no fun, and it will diffuse through gloves and through your skin, which is unpleasant and scary. So I'm going to go ahead and do that off camera. And once again, don't drink this stuff under the sink like I do, um, because this is how you end up with like a super fun site, and the EPA gets really mad again, and I have to tell them that I was just trying to clean a calculator off or whatever. All right, so I'm pretty happy with how this plate turned out. Um, just used some green spray paint. I waxed the outer edges that are going to be exposed so that the paint doesn't get worn off by grease or whatever. Okay, so here's the finished keyboard assembly. I wanted to point out a couple things in case you're trying to rebuild one of these, because this took me a couple hours, I think, to put fully back together. And at first I tried doing it in the machine, and I was having a lot of issues with these sliders in here. So I'm going to point these out. So on this side, we have the little green guy. It's green on mine because I just spray painted it, but this thing corresponds to the keyboard clearing. There's like a little thing on the side of the machine I can point out, but this has to be in this position so that when you push the clearing button, or when it's triggered automatically by the machine, it pushes this lever, which clears the keyboard. I can show that here by pressing some keys down. There we go. And then you go pop, and it clears them. And there's also this slider, which is attached to this thing, which is, I think, possibly even harder to get in the right spot. So the reason this is, it's harder to do out of the machine, because when it's in the machine, the keyboard kind of, whatever those rails are, keep these aligned. So when you're trying to put this plate back on, just sitting on something, these are going to be flopping all over the place, and getting them all in exactly the right spot's pretty hard. But it's kind of necessary, because then This piece right here, this little linkage member is the term for this, but it hinges from the plate here, and there's a little hinge here on the bottom, and it has to be exactly inside of this slot right here because it's on the, it attaches to this rail. So with that one, and then of course they have to slide within the keyboard top plate itself, which I can show here. Let's see. So this is the keyboard release. We got all four of them going. All four of those little slots. And then this one we got, should just be one of them, one set. Yep, so that's attached to that set right there. But I'm going to go put this back in the machine. I had some casualties taken on the fresh paint job here, but I'm hoping that maybe I can cut some corners and then it will work out very well. Yes, see, I'm already liking this progress I'm making here with the green Sharpie. I might have to, yeah, that'll buff right out. Anyway, there's the keyboard assembly. Alright, here's the thing, pretty much finished. I'm not sure I'll be able to do much else in terms of beautifying this thing. I am still missing the little cover that goes where the crank, that's where you would have a crank, and in this model there's supposed to be like a little plastic knob there. And I don't know. I mean, obviously that's not great to just have it in there like that, but let's see, I'll just run through a few things here. I'm going to do 9, 7, whatever this is, times 45. Yep, we got all 5s. I'll do the classic approximating pi. What is it, like 355 divided by 113. And there it is. I mean, I think it's more fun to use this thing than something like this larger Monroe over here, because if you want to divide anything or multiply anything, it is kind of a involved process involving the little knob guy down here. Which, I mean, a lot of these components I polished that aren't really supposed to be polished. Like this was painted before, and I just decided that I would polish the knobs, which is just an objective statement of fact. There's nothing funny about that at all. I think I had pointed out that these numbers up here, especially on the counter, were I really messed them up by trying to clean off the wheels with alcohol, and I really tried to fix those as well as I could with a stamp and like stamp ink, and but that was not working. So I ended up just taking I mean, that one's obviously I just like used a Sharpie, and then with the red ones I just tried to paint them a little bit. Unfortunately, I'm not good at painting. I can barely write as it is. I do not have good dexterity. It's as I was trying to struggle through that, it was really it's a chilling thought that there are people out there that just like to restore things that don't do anything, and this is why they do this, is so they can do stuff like paint. And it's really scary. These people are on YouTube, like they do this, like people that doing woodwork, and they just like sanding and painting, and like that's the end game. They don't want to make something and fix something that actually does stuff. But I'm getting better at it. These things are. I have learned that there are some paints that Monroe uses, especially in some plastics. Whoever the paint and plastic department is at Monroe back in the 30s pretty much decided, hey, let's make this button out of celluloid acetate. But only that one. So I'm in here cleaning all these things, and I get to that, and I get a strong whiff of celluloid acetate in the face, and I was like, oh yeah, that's what that is. These are not celluloid. the paint on this, like, I don't know why the yellow paint on here took weeks with the strongest paint that are known to man. Laboratory grade. It's banned for sale. And some of this other paint, like the stuff on the buttons, just came off from me looking at it wrong. But all in all, I mean, for like what? This was $30. This is one of those machines where I don't buy the expensive ones that are like, hey, $200 on eBay for this thing that's like, it works and it looks good. Or maybe it just looks good. I buy the ones that are like, hey, this thing's just garbage. It's on sale for $30 because no one will buy it. And I'm like, that's me, just jackpot, you know. But as a result, I've had to do a lot of painting, and I'm hoping I get better at this stuff over time. All right, I guess to finish this up, this machine doesn't do automatic division or multiplication, obviously, but there's another model that has the little switch up here for automatic division. But I figured I would demonstrate the Monroe method for. I think I'm gonna do like a root mean square here, just for like to show that there are ways to do things that were designed for getting around the fact that machines were so simple. But okay, let's do. I guess we're gonna do 14 squared plus 7 squared. So ordinarily this would be very challenging to do without division, squaring, but I'm going to go ahead and show how this. I mean, it's a little involved, but it's not that bad. So I'm going to start off by doing 14 squared, and I've placed the decimal indicators to kind of help with that. But let's see, 14. All right, I'm going to do 7 squared. So that is, 245 is 14 squared plus 7 squared. Now, to use this table, it's not that bad. I mean, really, you have a list of these approximations that you can use to get, I think, like 5 decimal places of accuracy, which is pretty good. But nearest, you have to move the decimal over twice if you're less than or greater than 100 or whatever. So we're going to use 2.45, which is in between 2.47 and 2.38. And then these columns are just add and then divide. So we got 2421. So I'm going to go ahead and add 2421 to the whatever the highest digit is. Clear that. And what does it say? 245. 3112 is the divide number. So we're going to divide by 3112. Okay, and the correct answer is 15.652, and you have to move the decimal place 1 over basically because instead of using 245, we were using 2.45, which, whatever, it's like 2 decimals is 1 digit there, but being able to do that pretty fast, I mean, like, that's even faster than your standard, whatever, Babylonian method where it's like you just subtract the odd digits from it, but I don't know. I think that's pretty useful. It's a little more useful on this thing over here, but right now this is not working because as I was working on this, the automatic division, the system that does the underflow on this is basically the same system on this thing, but it is not working. So now I get to fix it again on this machine, but now I have more experience from working on this one for however long that took. But anyway, there's my little video on the LA 160X.